Welcome to the deep dive. Today we're tackling something really quite groundbreaking.
We are indeed. It's the general availability of D-Wave's ADVANTAGE2 quantum computer.
Exactly, and quantum computing.
Yeah.
Most of you listening probably get the basic idea, right? It's not just D's and 1s like our laptops.
Right. It uses qubits, superposition, entanglement. It's a whole different way to compute. It's not just about raw speed necessarily, but tackling problems that are, well, basically impossible for classical computers.
And this D-Wave news, we're looking at their press release, the tech specs. It feels like a real step forward.
It seems that way.
So our mission today, really get into the hood of ADVANTAGE2. What is it? Why is it a big deal? And, what could it actually do for you?
Sounds good. Let's dive in.
Okay, so the big news dropped May 20th, 2025. ADVANTAGE2 is out there, generally available.
Yep, their 6th generation. And they're making some pretty bold claims, suggesting it can outperform even, huge exascale GPU supercomputers on certain hard problems.
That is bold.
Yeah.
That's the kind of claim we need to unpack.
Definitely.
So let's look at the tech specs. Why is it such a leap? Qubits first off, over 4,400.
Yeah, 4,400 plus. That's a solid number. Lets you represent bigger problems, obviously.
But it's not just the number, is it? It's how they're connected.
Exactly. That's maybe even more crucial. They're using this Zephyr topology. Gives you 20-way connectivity for each qubit.
20-way. How does that compare to before?
It's denser, more connections than their previous ADVANTAGE system. Think of it like more pathways for information to interact. It lets you map more complex, more sort of tangled problems onto the hardware more naturally.
Okay, so you can represent more intricate relationships within the problem itself. Makes sense.
Especially for things like material science, maybe drug discovery, where the interactions are really complex.
And couplers, it mentions over 40,000 of those. What's their role?
The couplers are what mediate the interactions between the qubits. It's fundamental to how quantum annealing works, D-Wave's approach. More couplers, denser connectivity. It just means a higher fidelity mapping of your problem onto the chip.
Got it. So more qubits, better connections.
Yeah.
And the performance numbers look pretty good too, right, from the datasheet?
They do. They're reporting a 40% increase in energy scale.
Which means?
Basically, it relates to the energy differences between possible solutions. Higher energy scale can potentially lead to more accurate answers, especially for optimization tasks.
Okay. And coherence. That's doubled.
Yeah, a twofold increase. Coherence time is, how long the quantum state stays quantum before degrading. Longer coherence means you can run deeper, more complex computations. It's really important.
Right. And maybe the headline grabber for reliability, 75% less noise. That's a fourfold reduction.
Huge. Noise is the enemy in quantum computing, leads to errors. Reducing it that much, that points towards much more stable, reliable results.
And they mentioned a faster anneal time.
Yep. The anneal is the process where the system settles into its lowest energy state, which is the solution. Faster anneal means, faster solutions, and it also makes the system less susceptible to, external vibrations or magnetic fields messing things up during the computation.
Okay, so faster, more coherent, way less noisy, yet somehow the power consumption hasn't gone up. Still 12.5 kilowatts, same as previous generations.
That is pretty remarkable, isn't it? It speaks volumes about their engineering efficiency over the years.
It really does. So how do people actually use this improved power? It's not just the chip itself, right? There's the hybrid approach.
Crucial point. ADVANTAGE2 is tightly integrated with their Leap cloud service, and importantly, their hybrid solvers have been upgraded. They can now handle problems with up to 2 million variables and constraints.
Whoa, okay. 2 million. That sounds like it's definitely moving into the realm of, serious large-scale business problems, not just lab experiments.
Absolutely. These hybrid solvers are key because they blend classical computing strengths with the quantum processor's power for specific parts of the problem. It lets you tackle these massive business-critical applications.
And it's accessible. People don't need to buy the fridge-sized machine themselves.
Not necessarily. It's available right now through the Leap cloud service. D-Wave says it's accessible in over 40 countries, high uptime, SOC2 Type 2 compliance for security.
So the barrier to entry, at least to try it out, is relatively low.
Much lower than buying the hardware, yeah. But for those who do need or want it on-site, think hyperscalers, national supercomputing centers, they can purchase it for on-premises deployment.
Right. And D-Wave's been doing this a while, haven't they? Deploying systems since 2011.
They have. That track record, that operational experience, it does count for something in this field. Shows a certain maturity.
Okay, so we've got the hardware improvements, the hybrid software, the accessibility. Let's talk applications. Where is this actually making a difference?
D-Wave's targeting areas where complex optimization is key. So think supply chains, logistics, factory scheduling, operations research, that kind of thing.
The classic optimization problems where even small gains save big money.
Exactly. Also, material simulation, which we touched on, and pushing forward AI and machine learning.
What about financial modeling or decision support?
Yes, definitely. Portfolio optimization, risk modeling. Areas with complex interdependencies are good candidates. And for AML, the idea is to accelerate training or enable new types of intelligence systems.
And it sounds like people are actually using it. The press release mentioned, what, over 20 million problems run on the prototypes?
Yeah, since June 2022, and they said usage picked up significantly in the last 6 months. That suggests people are finding real value, moving beyond just kicking the tires.
Are there specific examples? Customer validation?
There are. Los Alamos National Lab, for instance. They've been using a prototype for research into condensed matter physics, magnetic materials. Apparently getting results they're preparing for peer review.
That's serious scientific validation.
It is. And Davidson Technologies has one on-premises for national security research.
Okay, so government and high-level research.
Mm-hmm.
What about industry?
Japan Tobacco did a proof of concept combining quantum and AI for drug discovery using a prototype. They reported better learning accuracy in large language model training with fewer parameters.
That's interesting. Yeah, that sounds potentially very impactful. Drug discovery is huge.
And they plan to use the full ADVANTAGE2 now to speed that up. Then there's the Jülich Supercomputing Center in Germany.
Right, they're planning to upgrade and connect it to their big exascale machine, Jupiter.
Exactly. That kind of tight integration between top-tier classical HPC and advanced quantum, that could unlock some serious capabilities, especially for AI and optimization research in Europe.
In Ford Otosan, the vehicle production example.
Yeah, they use D-Wave tech in a hybrid setup for optimizing vehicle production sequencing. They reported a 6x improvement in how fast they could generate the schedules.
6 times faster scheduling.
Yeah.
That's a tangible operational benefit right there.
Absolutely. These are the kinds of results that get businesses interested.
And we should probably mention that quantum supremacy demonstration D-Wave did on a prototype.
Ah, yes, the magnetic materials simulation. They claimed it finished a task in minutes that would take like 1,000,000 years on a classical supercomputer.
Now, okay, 1,000,000 years is obviously a theoretical estimate, but it highlights the kind of problem where quantum annealing just fundamentally changes the game, right?
Yeah.
Where classical methods hit a wall.
Precisely. It shows there are specific, complex problems where this different computational paradigm offers an exponential advantage. It's not going to replace your laptop for email, but for these hard simulation or optimization tasks. It's a different beast.
So thinking about our listeners, if you're in business, what's the takeaway?
Potential for real gains in supply chain, logistics, finance, maybe accelerating AI projects where optimization is a bottleneck. It's becoming a tool to consider for competitive advantage.
And if you're a researcher?
The improved coherence, the lower noise. It just means you can tackle more complex, more realistic simulations and quantum experiments, maybe model systems you couldn't accurately model before.
And for the national labs? Government sector.
Tailored configurations, integration with existing HPC. It's about building powerful hybrid workflows to tackle really big mission-critical computational challenges.
Okay, so if someone's listening and thinking, this sounds relevant to my work, what should they do next?
Best bet is to head to D-Wave's website. Lots of info there. And they have that webinar coming up on Juneteenth. That would probably be a great place to get more details and ask questions directly.
Right, good pointers. So wrapping this up, it really feels like the general availability of ADVANTAGE2 marks a, well, significant moment.
I think so. It's a combination of substantial hardware improvements, the Qubits, connectivity, coherence, noise reduction, plus the mature hybrid software and the cloud accessibility.
In the growing list of real-world use cases and validations, it's moving beyond promise towards actual utility.
Exactly. Quantum computing, particularly D-Wave's annealing approach, seems to be finding its footing as a practical tool for certain classes of hard problems.
Okay, so final thought for everyone listening. As this technology, quantum computing in general, gets more powerful and easier to access, what problems that seem completely out of reach today might suddenly become solvable?
Yeah, and what entirely new questions could you start asking in your field, knowing that this kind of computational power is becoming available?
It definitely opens up some fascinating possibilities. Something to think about. Thanks for joining us for this deep dive.